Welcome. Today we look at how Snowflake acts as a control plane spanning across AWS, Azure, and Google Cloud. Think of Snowflake as the brain, while your specific cloud storage serves as the muscle. Instead of choosing just one provider, Snowflake allows you to use a single interface to manage data across multiple providers. You command the data, and it flows wherever you need it. The main benefit is simplicity. You don't have to manually configure 3 different cloud infrastructures. It's one interface for all your data. Multi-cloud resilience in Snowflake rests on 2 main pillars: replication groups and failover groups. Replication groups let you selectively mirror databases and objects. You choose what data travels across your cloud regions, keeping only what is essential in sync. Failover groups take resilience further. If a primary cloud provider faces a major outage, these groups allow you to automatically promote a secondary cloud to primary status. This ensures business continuity with recovery times under a minute. It effectively turns different cloud providers into your own distributed availability zones. Managing security policies across different cloud providers can be a massive headache. You have AWS, Azure, and Google Cloud, each with its own way of doing things. Snowflake Horizon changes the game. It acts as a single governance layer, meaning you define your security and compliance policies exactly once. Once defined, these policies persist automatically across every cloud region and provider. Your clean rooms, data privacy, and access controls remain consistent, regardless of where the physical data lives. By using Snowflake Horizon as your unified control plane, you spend less time managing silos and more time extracting value from your data. That's the power of unified governance. Moving massive data sets across cloud regions creates huge egress costs. To stay efficient, modern architectures use tools like Snowpipe streaming. The core strategy is simple: keep the heavy processing where the data lives. By running inference models locally using Snowpark container services, we process raw data without moving it. By only syncing high-value insights or metadata back to your main hub, you keep egress costs at an absolute minimum while maintaining performance. When architects design multi-cloud systems, they often encounter the latency tax. This is the performance penalty and extra cost you pay when moving large data sets across cloud boundaries. The golden rule for your architecture is simple: keep the compute where the data lives. Pulling data from 2 different clouds across the public internet is slow, expensive, and unreliable. In a hub-and-spoke architecture, remote connections introduce bottlenecks. Instead of pulling raw data to a central hub for every query, we want to perform heavy transformations locally. The best practice is to transform data locally within each cloud. Once you have prepared your results, only share the final insights across your multi-cloud environment. This avoids the latency tax and keeps your costs under control. Many companies move to multi-cloud architectures for regulatory arbitrage. Different regions have strict laws like GDPR in Europe or CCPA in California regarding where data must live. A financial firm might keep primary operations on Azure, but mirror sensitive records to a sovereign AWS region. This ensures they meet local banking laws without creating isolated data silos. Snowflake makes this seamless. It acts as a unified control plane, allowing you to meet data residency requirements while maintaining a single, coherent view of your global business. Key takeaway: regulatory sovereignty is about balance. Use multi-cloud for compliance, but use Snowflake to keep your data governed and visible. Multi-cloud is a powerful tool for FinOps, or financial operations. Cloud pricing fluctuates, and a multi-cloud strategy allows you to shift workloads where compute is cheaper. Think of Snowflake as your portable engine. When one provider raises rates, you can easily shift non-critical workloads to where they are more cost-effective.